Chapter 15, Part 1, we are going to look at the addition rule again, and we will look at Venn diagrams. So technically there are two different addition rules. One addition rule is for mutually exclusive events. These are events that have no overlap, or these cannot occur at the same time. We said that when we're finding the probability of A or B, we just add the two probabilities together. Again, we can do just this simple addition if they are mutually exclusive. Today we're going to talk about the addition rule for events that are not mutually exclusive. So this means there are some overlap in the events, or these events could occur at the same time. So the formula is given to you here. If I'm finding the probability of A or B, I'm going to start with taking the probability of A and adding it to the probability of B. But because there is an overlap, what actually happens is I double count the overlap. I count it in the probability of A and in B. So I have to subtract the overlap. This part right here is the overlap. And that overlap we denote as the probability of A and B. So I think this is best seen through an example. So I'm going to look at number 1. It says a single card from a deck of 52 cards is drawn by random. What is the probability that it is a heart or an ace? For hearts, I'm going to use just a literal heart, and for ace, I'll use A. Now I'm finding the probability of heart or an ace. So I'm going to start with using just my notation here. I'm going to start with finding the probability of a heart and add it to the probability of an ace. Now eventually we will do some subtraction here, but I'm going to save that till the end. If you don't know your cards from just a standard deck of cards, I would make sure you start to look over those. If you just do a quick Google search of card sample space, it'll give you your 52 cards. So we have our 4 suits. We have clubs, spades, hearts, and diamonds. Mine printed in all black and white, but hearts and diamonds are both red. So I'm looking for the probability of a heart. So there are my hearts here. There should be 13 of them out of 52. And then I'm adding it to the aces, which I have 4 aces. Now, so far, if I'm looking for a heart or an ace, I'm assuming based on this addition, there's going to be 17 cards. If I look back at my sample space here, my hearts are 13, so I've got those 13, and then I'm also looking for or ace, so I would add 1, 2, 3, because there's 3 more cards that are aces. That would only give me 16. And the reason for that is because this ace of hearts is counted in both the aces and in the hearts. So that's where that idea of subtraction comes from. Because it's possible to have a card that is both a heart and an ace, I have to subtract that overlap. There was only one card that was an ace and a heart, so I'll subtract 1 out of 52. There's multiple ways that you can do this. I personally like to simplify the fractions before typing in my calculator. So 13 plus 4 would be 17, minus 1 gives me 16 out of 52. And then I can type in 16 out of 52 into my calculator to give me 0.3077. So looking at a standard deck of cards, there's about a 30% chance that I pick either a heart or an ace. Okay, number 2 says a single card from a standard deck of 52 cards is drawn by random. What's the probability that it is a heart or a spade? So now I'm looking for heart or spade. Hopefully you can tell that's a spade. Again, I'm going to start with my addition. So probability of heart plus the probability of a spade. And I'm going to subtract any overlap. Okay, probability of hearts. There are again 13 hearts in my deck of cards. And there are also 13 spades. Now, when I look for this overlap here, are there any cards that are both hearts and spades? No, they're either a heart or they're a spade. They're different suits. They cannot happen at the same time. So technically what's happening here is this is 0 out of 52. Now, because this probability of them happening at the same time is 0, I don't really need this subtraction. Hearts and spades are mutually exclusive, which is why these formulas look so similar. When there's no overlap, you're still technically subtracting. It's just you're subtracting 0, so it doesn't make a difference. So finishing this problem, 13 plus 13 should give me 26 out of 52, which should be 0.5. 50% chance that I pick either a heart or a spade. Go ahead and pause your video. I want you guys to try number 3. Here's the work for number 3. This one's very similar to number 1. There was an overlap because it is possible to get a king of clubs, so make sure you're subtracting that overlap, giving you 0.3077. And I do want to go through number 4 with you. It's very similar, still using that addition rule, but this time we're not using cards. Instead, they're just going to give you probabilities. So it says the probability of a person having a car accident is 0.09. The probability of a person driving while texting is 0.32. The probability of a person having a car accident while texting is 0.15. What is the probability of a person driving while texting or having a car accident? So we're looking for the probability that they are texting or they have an accident. So I'm going to use T for texting, A for accident. Using my formula here, I'm going to take the probability of texting, add it to the probability of a car accident, and if there's an overlap, we'll subtract it. So the probability of somebody texting while driving, they give me is 0.32, plus the probability that someone has an accident is 0.09, and the probability that they text and have an accident, so have a car accident while texting, is 0.15. So we get 0.26. The biggest mistakes that students tend to make when working with the addition rule is we forget about subtracting the overlap. I recommend always writing out the overlap here when you're working with your notation. If there isn't an overlap, then you can just put the 0, because again, subtracting that 0 won't make a difference. On the next page here, we're going to switch gears and talk about Venn diagrams. Reading Venn diagrams and using them to determine several different probabilities is a very common and important skill that you want to make sure you're able to do. So here we have a Venn diagram. They're giving me event A in this circle, event B in this circle. We know that the sample space should add up to 1, so I like to start with finding anything that's on the outside there. So if I take 1 and I subtract 0.15, subtract 0.1, and subtract 0.3, that gives me 0.45 left on the outside. So that's the probability it's not in event A or B. Okay, we're going to go through a bunch of probability questions here. I'll give you kind of some tips and tricks to use as you are reading these Venn diagrams. The first one asks for the probability of A. This means I want the chance of something being in event A. I need to look at this entire circle for event A. So I have 0.15 and I have 0.1, so in total I would have 0.25. A little bit tricky, you want to make sure you're looking at the entire circle, not just this part on the outside. Number 2 says find the probability of B. Again, I want that entire circle for event B. So 0.1 plus 0.3 gives me 0.4. Number 3 says find the probability of A or B. So this means I want to look at everything that's either in A or in B. So I'm looking at everything in these circles here. So I'm taking 0.3 plus 0.1 plus 0.15, which should give me 0.55. Okay, A and B means that I'm looking for things that are definitely in both events. So they have to be in event A and in event B. This and you can think of as an overlap. The only time where event A and B overlap is at the point 1. Okay, getting a little bit trickier here. In number 5, they're asking me to find the probability of not A. This is the complement of A. So what I want to do here is I'm visually going to look at this and I'm going to cover up everything that's in event A. So these guys are in event A. I'm left with the 0.3 and the 0.45. Those are things that are not in A. So adding up the 0.3 and the 0.45 gives me 0.75. You could also use your complement rule and take 1 minus the probability of A. We found the probability of A was 0.25, and 1 minus 0.25 is still going to give us 0.75. Not B, remember that little c is again just the complement, so this means we're looking for not B. Again, I'm going to cover up everything in B. I'm left with 0.15 and 0.45. which gives me 0.6. Again, you could use this complement rule if that's easier for you. Okay, as we get a little bit harder here, you'll start to see some parentheses. As we see parentheses, I'm going to use what we call the dot method. Anytime that I have ors, I am going to count all dots. Anything that's an and, I'm only going to count double dots. Ors, I want to include anything that's talked about, and it's only looking at the overlap. So, for example, in number 7, I'm looking for A, or it's not in B. So I'm going to start with putting dots in everything that's in A. So I would have a dot here and here. And then I'm going to also put dots for the second piece, so I'm looking at stuff that's not in B. So not in B would be this and this. Now I want or, so I want everything that's in A or not in B, so I would count everything that was dotted. So I would do 0.15 plus 0.1 plus 0.45, and I get 0.7. Okay, if you look down at number 9, the only difference between 7 and 9 is the or versus the and. If it's an and, it means I'm only looking for where these two things overlap. So looking at my dots here, I had a dot at the 0.15 and the 0.1 for A, and then for not B, I had a dot at the 0.15 and the 0.45. The only part that was double dotted, or the only part that was in A, and also was not in B, was the 0.15. So again, and you're counting double dots, or you're counting everything that was dotted. Okay, we'll take a look at 8 and 10. 8 wants everything that's not in A. So not in A would be the 0.3 and the 0.45. Or it's in B, so I'll dot everything that's in B. So I'm going to add all those up, and I should get 0.85. 10 says the probability of not A, so again I would put dots on 0.3 and 0.45. And then B, but I want and for overlap, so the only time I have a double dot was that 0.3. Make sure if you're using that dot method that you are erasing after each time. Okay, and then 11 and 12 are tricky because they give us a complement on the outside of those parentheses. So I'm going to show you two different ways to solve these. One thing that you could do is distribute this complement into every piece in your parenthesis. So this would change into the probability of not A, not an and actually changes it to an or, and then complement of B. So now I don't have to worry about this complement on the outside. I've distributed it in, and it's now the complement of every piece. So I'm looking for not A. So not A would be the 0.3 and the 0.45. I'm also looking for not B. So that's the 0.15 and the 0.45. It's an or, so I'm adding everything that was dotted, so 0.15, 0.3, 0.45. The only thing that's not in there is the 0.1, so this should be 0.9. Okay, another thing you could do if you didn't like that distributing is you could find what would be in the middle here and then take everything else besides that. So in the middle, I'm looking for A and B, meaning I'm looking for the overlap between A and B. A and B overlap at 0.1, but I don't want that. It's the complement of that. So I would do 1 minus 0.1, which would give me 0.9. Either way, you should get the same answer. I personally like the distributing because then it turns it into a problem just like we saw 7 through 10. Okay, so 12, same kind of thing. We have a complement on the outside of our parentheses. I'm going to distribute it in. So I have the probability of not A or complement changes it to an and, not B. So again, using my dot method, I am going to put dots on everything that's not in A. So the 0.3 and the 0.45. And I'm putting dots on everything that's not B. So the 0.15 and the 0.45. And means I want where they overlap, which is double dots. So that was the 0.45. If you didn't like that distributing, again, you could start with finding just that inside piece. So A or B. A or B means everything in here. So I would have 1 minus 0.55, which again gives me 0.45. On page 19, we'll continue working with Venn diagrams. This time, they're going to give you some kind of scenario, give you numbers or probabilities. It's our job to first fill in the Venn diagram, and then we'll answer some probability questions about the Venn diagram. So 13 says, Erin's job at Jewel Osco takes up a lot of her time, but she also works on homework after school. She collected data for a total of 30 days. Erin worked at Jewel Osco 18 days and worked on homework for 8 days. There were only 5 days when she worked on homework and worked at Jewel. If event A is working at Jewel, so I'm going to put Jewel here, and event B is working on homework, use the information to fill out the Venn diagram. Now, whenever you're filling out Venn diagrams, you always want to start in the middle, looking for overlap. So does it tell us how many days she worked at Jewel and did homework? Well, homework and Jewel was 5 days. And it also tells me that Erin worked at Jewel for 18 days. Now, this is a total. It doesn't say total, but it's not saying that she only worked at Jewel. It's saying that she worked at Jewel for 18 days. So I don't want to put an 18 here because that's not considering the 5 days that she worked on homework as well. So I need to take that 18 and subtract 5. So there's only 13 days that she only worked at Jewel. It also says she worked on homework for 8 days. Again, I don't just want to put an 8 here because that's not considering this overlap. There's already 5 days in the middle. So 8 minus the 5 gives me 3. It did tell me she worked for a total, or she collected data for a total of 30 days. So I'm going to take 30 and subtract everything I have written down there. That means there are 9 days that she didn't work at Jewel, and she didn't do any homework either. Part A says, what is the probability that on a randomly chosen day, Erin works at Jewel, but she does not work on homework? So I'm looking for a notation. I want her to work at Jewel, and she does not work on homework. So I'm going to do the complement of H. So I'm looking for Jewel here, but she cannot work on homework, so I don't want to include those 15 or the 5 days in the middle. So this would be 13. And this is a probability, so I need it to be a percentage. So I'm going to do 13 out of the 30 days total. 13 out of 30 gives me 0.433. Why don't you go ahead and pause your video, try B and C, and then I will show you my work. Here is my work for B and C. For part B, we are looking for her not working at Jewel and not working on homework. So nothing in these circles, we're just looking at the 9 on the outside. Part C said the probability that she works on homework or works at Jewel. So I'm looking at everything in the circles, which ends up to 21, gives me 0.7. I want to do one more Venn diagram with you. Number 14 has a small typo. It says, while fishing one morning, Caden caught a total of 23 students. Go ahead and change that to fish. He's not catching students, he is catching fish. Caden caught 6 fish that are small and brown, 10 fish that are only small, and 5 fish that are only brown. We want to use the information to fill out the Venn diagram. Now to me, it looks like the two things we're talking about are whether the fish are small and brown. So I'm going to make one of these for small fish, one of them, for brown. Okay, again, I want to start with that middle. So I'm looking for fish that are both small and brown. It says he caught 6 fish that are small and brown. So I'm going to put 6 in the middle here. It says he has 10 fish that are only small. Now that word only means that they are not brown. They were only small, so I don't have to do any subtraction here. I can just go ahead and put the 10 right there. They're being very specific here, telling you that these guys are only in this one category. If you see that word only, it typically means you don't have to subtract the overlap. 5 fish are only brown, so 5 goes here. It does say that he caught a total of 23 fish. 10 plus 6 plus 5 would be 21. So there would be 2 fish on the outside here that were neither small nor brown.